Database administrators often use views to combine, transform, and present data in a form that's easy to process and query by the application. They're easier to maintain and optimize than a complex query statement that's developed and maintained in one or more applications. Using Spring Data JPA, you can map and query views in almost the same way as database tables. Hi, I'm Torben Jansen. Today I will show you the best way to use database views with Spring Data JPA. But before we proceed, if you're new here and want to learn how to create your entity mappings with ease, build incredible efficient persistence layers with Hibernate and Spring, and all types of other Java persistence-related stuff, subscribe and click the bell to get new videos every week. And also don't forget to like this video if you found it helpful. By doing so, you are helping me to reach more people with it. Okay, let's get back to our topic. If you compare an SQL statement that selects data from a view with one that selects the same data from a table with the same structure, you will not see any difference. Because of that, you can use your regular set of annotations to model an entity that maps your view. And in your query, you can use it in the same way as any other entity. But depending on how you define your view and the capabilities of your RDBMS, the view might not support write operations. In that case, I recommend modeling an immutable entity and a read-only repository. It not only prevents all write operations, but also improves the maintainability and performance of your application. If you can't update the data in your view, you should model a read-only entity. As I explained in my Hibernate tip on mapping views, this enables your persistence provider to apply internal performance optimizations. For example, exclude the entity objects from all dirty checks. You define an immutable entity in almost the same way as any other entity. You can use the same mapping annotations, and you, of course, need to fulfill JPA's requirements of an entity class. It has to be a public, non-final class with a default constructor and non-final attributes. You also need to define at least one attribute that identifies each object. In addition to all of that, you need to annotate your class with immutable. This annotation tells Hibernate that the entity object will not change. Hibernate will exclude it from all dirty checks and will not trigger any SQL update statements. But be warned, Hibernate doesn't ensure that you will not change any entity attributes. It will just not trigger any SQL update statements. You should therefore not provide any setter methods. Making your entity class immutable is the most important step to working with database views in Spring Data JPA. Based on this mapping, Hibernate will ensure that your application doesn't perform any write operations on the view. To make your persistence layer easier to use, you should take this one step further and also exclude all methods from your repository that persist, update, or remove an entity. All standard repository definitions provided by Spring Data JPA support read and write operations. If you want to create a read-only repository, you need to define it yourself. But don't worry, you don't need to provide any implementation for the read operation. You only need to define an interface, and you can use all standard methods provided by one of Spring Data JPA's standard repositories. I always like to define my read-only repositories in two steps. I first create a reusable read-only repository definition that I then extend and customize for each immutable entity class. The two things you need to do to create your own repository definitions are defining an interface that extends the repository interface and copying a few method definitions from Spring Data JPA standard repositories. In this example, I copied the findAll method from the JPA repository and two findAll methods from the paging and sorting repository, and the findById and count methods from the CRUD repository interface. As you can see here, I didn't specify the generic types in my read-only repository definition. We do that in the next step when we create the entity-specific repository version. And I also annotated the interface with no repository bean. That annotation tells Spring Data JPA not to create an instance of this interface. Based on the read-only repository definition, you can then define your entity-specific read-only repositories. To do that, you extend the interface definition in the same way as you extend any of Spring Data JPA's standard repository definitions. As you can see here, I specified the type of the entity class and of the primary key attribute. And I also added a derived query that returns all games played in a tournament with the provided name. In your application, you can then use the repository in the same way as any of your other repositories. The only difference you will recognize is that the chess game view repository only provides the find by tournament name and the 5 methods inherited from the read-only repository. You can read data from views in the same way as you read it from a database table. Because of that, it's no surprise that you can map them in almost the same way. The main difference is that views are often read-only and you need to prevent any write operations. You can do that by annotating your entity class with immutable and defining a custom read-only repository. The annotation tells Hibernate to exclude all objects of that entity class from all dirty checks. Due to that, it will not trigger any SQL update statements, and you can define a read-only repository by extending the repository interface and copying some method definitions from Spring Data JPA standard repositories. Spring provides an implementation of your repository definition and all its standard methods. You can also use derived queries to let Spring generate and execute custom queries.